Hi guys, this is Miss Scott here, and we are going to jump into Chapter 9 today. So Chapter 9 has to starts out with translating figures and using vectors. So our essential question is, how do you translate a figure using a vector? So we're going to get into what a vector looks like a little bit later in this lesson, but we're going to start with a translation. And just to put some context to that, we're going to just jump right into an example. So right here we're told to graph quadrilateral ABCD with these vertices here and find the image of each vertex after the translation x comma y goes to x plus 3 comma y minus 1. So all this is saying is you're going to take every x value, add 3 to it, and then take every y value and subtract 1. And then we're going to end up with a new image. And this prime notation we'll get to. So to start out, I'm just going to write down A is at negative 1 comma 2, B is at negative 1 comma 5, C is at 4 comma 6, and D is at 4 comma 2. So those are just listed above. All right, so let's go ahead and graph those 4 points. So A is at negative 1 comma 2, so we better put a A by that point. B is at negative 1 comma 5. Oops. So that is point B there. C is at 4 comma 6. So we go right 4, up 6. And D is at 4 comma 2. All right, so we've got this quadrilateral here. Oh, I think D needs to go one more to the left, 4 comma 2. There we go. So here we go. Now we're going to apply that translation rule. And all a translation means is just a slide from one point to another. All right, so if we add 3 to negative 1, A prime, we call that the translation, or the image of A is actually the correct terminology there. So negative 1 plus 3 brings us to 2. And 2 minus 1 is going to bring us to 1. So what A prime did is it moved right 3 and down 1. So there's the point 2 comma 1. And we call that A prime because it's the new A. All right, same with B. If we add 3, we get our B prime at 2 comma, subtract 1 from the y, and we get 4. So if we go over 2 and up, 1, 2, 3, 4. So what we would call B prime. Same with C. Add 3 to the x, so we get 7. Subtract 1 from the y, and we get 5. Over 7 and up 5 would be 1, 2, 3, 4, 5, 6, 7. Up 1, 2, 3, 5. That does not look right. Let's try that again. I think my B prime is up 1 too many, so this is over 2, up 4. So B prime should be right there. Knew something didn't look right. Okay, so now for C prime, that was over 3 and then down 1. So there we go. And lastly, for point D, it's going to be to 7 comma 1. Whoops, and that would be D prime at 7 comma 1, so over 7 and up 1, so there would be D prime. Now you probably notice that this has the same shape, it's just moved. When something stays the same size, but then it's just moved, we call that a translation or a slide. So what we've got going on here is we call that original figure the image. So that was just what we graphed right away. Actually, let me re-say that. The image is after you moved it. So it's the A prime, B prime, C prime, and D prime. The pre-image is before you moved it. So that was just that quadrilateral ABCD. And this word here, isometry, That means the figure doesn't change its size. So it stays the same size. Okay, another word for a translation, that's what we just did here, is a slide. So the figure slid 3 to the right and then down 1. So we'd call that a slide. Now, vector coordinate form for this specific problem, it's that rule where we started with x comma y, and then we did x plus 3 and y minus 1. We call that vector coordinate form. Okay, vector component form would be if you took your x and y, and then we use these triangular brackets here, and the first coordinate is just how far you moved to left, right. So it's positive 3 because it was to the right, and negative 1 was down. So you really just use how it's moving, the plus 3 and the minus 1 for these two numbers. Okay, so let's take a look at a couple more examples here. Two definitions before we get too far. We've got, first of all, a vector. A vector has two things. It has a direction, so you gotta know which way it's going, and a magnitude. And another word for magnitude is its size. So it's got size and direction. And then what we call a resultant vector is simply a vector from the beginning point to the ending point. So it's like from A to B without how you got there, just if you were going to draw a line right from the beginning point to the ending point. All right, so now let's look at two examples here. To name a vector, it's very similar to naming a segment, but the order is important here. So notice that this arrow points from V to W. That means we have to start with letter V and then go to W, and then we put this symbol over the top. So it's kind of like the top half of an arrow. That means vector VW. And then we're going to name it in component form. So that just tells us we got to use these triangular brackets. And notice we always go left, right first. So notice to get from V to W, we had to go left 7, so that would be a negative 7 for the x coordinate. And then we went down 3, so that would be a negative 3 for the W. All right, so you always go left, right, and then up or down. Okay, let's try another one here. So notice we start at A and then go to B. So this would be vector AB. And we go right 2, so this would be a positive 2. And we go down 6, so that would be a negative 6. So the vector would be 2 comma negative 6. All right, so a couple ways of naming vectors and the component form there. Okay, and vectors are very useful. They use them a lot in navigation just because it's easier to tell you how you get from A to B. So let's look at this example. A boat heads out from point A on one island towards point D on another. So we got this point A at the 0, 0, and then they go to B here at 12, 4. And the boat encounters a storm at that point, 12 miles east and 4 miles north of the starting point. So that's what this 12 comma 4 here means. And then the storm pushes the boat off course to point C. So then they end up a little bit southeast of where they were. And they're actually trying to get to this point D. So now they're a little bit off course. So we got to help them figure out how to get back on course there. So let's look first at the component form of vector AB. So notice to get from A to B, we had to go to the right 12. And that was a little too far. So right 12, positive 12, and then they went up 4. So 12 comma 4 would be the vector component form. And let's look at how about from B to C. So I'm going to grab a new color here. Let's do green, sure. So to get from B to C, first we go right. And if we're already at 12 to get to 16, we'd have to go up 4. All right. And then we started at 4 and we got down to 2, so that would be minus 2. So 4 comma negative 2 would be the vector. Okay, so now let's write the component form of the vector that describes the straight line path from the boat's current position C to its intended destination D. All right, well, we're at point C. We got to get to point D over here on the other coast. So we only have to go over from 16 to 18. We'd go over 2 miles, and then from 2 to 5, we would go up 3. So they need to go right 2 miles and then up 3 miles to get to their final destination. Oh, and I actually made a mistake there. These should be these triangular brackets. Okay, now we know like this boat got a little off track here, so let's start over. What if they didn't encounter a storm and they were able to get directly from point A here to point D without doing all that stuff in between? Well, they could just go over 18 miles. So their vector component form would be 18, comma 5. So they would want to just go directly from A to B. This vector right here would be a much simpler way of getting there than doing all this turning back and forth. So 18, comma 5 would be the quicker route if they didn't encounter that storm. Okay, so let's flip to the next page here. We're not going to look at graphing in these last couple of examples. We're just going to see if we know we got this rule, where we add 2 to the x and subtract 7 from the y, where would our points end up? So remember, the image is if you apply that rule to the point. So if we add 2 here and subtract 7 from here, 6 plus 2 would give us 8, and negative 3 minus 7 would give us negative 10. So we would call that A prime, would be our new point. Okay, this color is a little hard to see here. All right, same rule here. We start with B, and we're going to add 2 and subtract 7. So 0 plus 2 is 2. 9 minus 7 is 2. So B prime would be at 2, comma 2. All right, now in number 3 and 4, they give us the we want to find the pre-image if we know where C prime is. That means we're going to have to work backwards. Instead of adding 2, we're going to subtract 2. Instead of subtracting 7, we're going to add 7. So that means C, if you're trying to find the pre-image, what you're doing is you have to undo what was done to C. Well, if we undo that, we know that C was at negative 12, comma 49. So they gave us C prime and we found the original. All right, same idea here in part 4, subtract 2, add 7. That means D was at 2, comma 6. Okay, now we're going to make a couple of rules here, and we're going to do it in coordinate form. So remember, that's without those triangular brackets. So to the left, so we're going to start with an x comma y, and we're going to figure out the rule if we shift it 4 units left, so that would be in the negative x direction, and 3 units up, which would be in the positive direction. So we're going to take our x and subtract 4. We're going to take our y and add 3. So this right here would be the coordinate rule for that problem. Okay, and then in 6, they're just moving 11 units down. Well, they didn't move left or right at all, so we're going to start with x and y. The x is not going to change, but the y is going to be subtracted 11. All right, so that would be our coordinate rule for the translation. Now, if it asked for the vector component rule, This one would be negative 4 comma 3, but then it would be inside these triangular brackets. This one would be 0 comma negative 11, and again it would be in these triangular brackets. All right, well, thank you guys for watching. Don't forget to like the video and subscribe to my channel, and we will see you guys next time. All right, bye.